going to start off the Calc 1 video with an introduction to limits. An intro to limits. Next section, we'll do techniques of solving limits or evaluating limits. So I guess we need to talk about some notation for now. One would read this as the limit as x goes to 3. The arrow means goes to. The limit as x goes to 3, or the limit as x approaches 3 of x plus 2. What's the limit as x approaches 3 of x plus 2? That means if x is really, really close to 3, but not necessarily 3 itself. If x is very, very, very close to 3, what would x plus 2 be? Well, x is really close to 3. X is really close to 3. So you get really close to 3 plus 2. Well, if you're really close to 3 and you add 2, you're really close to 3 plus 2, or 5. And if you're really close to 5, for limits, we say you are 5. Basically, you just plug that number in for x. 3 plus 2 is 5. If we were going to look at a table to see that this is somewhat true, remember that x plus 2 is the function. So I'm going to take values, so we have x and we'll have f of x. And we'll take values close to 3, from below 3. Maybe we'll use 2.9, 2.99, 2.999. Notice I got closer and closer to 3, but always below 3. Now let's get closer and closer to 3 using numbers that are above 3. Like 3.1, that's close to 3. But 3.01 is even closer to 3. And 3.001 is closer to 3. And the last number is the closest to 3 that I wrote down. Well, what does f do to what's in the brackets? Well, x is in the brackets. What does f do to what's in the brackets? It's going to say so here. It takes what's in the bracket, it takes x, and it adds 2. So I'm going to take all my x's and I'm going to add 2. Get 4.9, add 2, get 4.99, you add 2, you get 4.999. I could get as close, and these numbers are getting closer and closer to 5. I could get as close to 5 as you like, so long as I let x be even closer to 3. Now, to the right of this line, the x's are all more than 3. Well, no matter what x is, to find f of x, you add 2. Get 5.1. Now that's somewhere close to 5. But here's an even closer number, 5.01. 5.001. Add 2 to this number, get 5.0001. It's approaching 5. When x was below 5, as I got closer and closer, it's approaching 5. Excuse me. When x was getting closer and closer to 3, f of x approached 5. These x values, 2.9, 2.99, 2.999, they're getting closer and closer to 3. And the y value, or the f of x value, is getting close to 5. Remember, another name for f of x is y. Okay, here we have some x values, and they're getting closer and closer to 3. You know what? The y values get closer and closer to 5. That is why the limit is 5. Now you can't always just directly substitute like I suggested. 3 plus 2 is 5. Sometimes that won't work. That's why I never say x equals 3. I say x gets close to 3. For example, if you look at the limit as x goes to 2 of x squared minus 4 over x minus 2. If you look at what happens when x equals 2, this is not defined. If I were to define f of x to be x squared minus 4 over x minus 2, well, when I plug in 2 for x, that is, I'm going to square 2, I'm going to take away 4, I'm going to put x in the bottom, which is 2, I'm going to take away 2. Well, 2 squared is 4. You get 0 over 0. In the next video, we're going to talk about this big times. This is said to be indeterminate. Don't worry about the words now. It'll come up in the next video, big times. But more importantly, we didn't get an answer. You can't divide 0 by 0. When you divide 8 by 2 and you claim the answer is 4, I can check that. 0 times 4 is 8. And that's always true. If you divide 48 by 12, you get 4. And I can check that. 12 times 4 is 48. Well, and only 4 works. Only 12 times 4 is 48. A lot of students may say, oh, this is easy, it's 0. Come on, 0 times 0 is 0. But you know what? I can have 83 here as well. 0 over 0 is 83. 0 times 83 is 83. I can put any number here, any number. I can put 1/3. I can put negative 1/3. After all, 0 times that number is 0. So we need to determine which number it is. And just by plugging in 2 won't work. We have to consider what happens when x gets close to 2. Well, I just want to show you an example right up front where you don't care what happens at 2, you care what happens near 2. For example, the numerator, if you were to factor it, is x plus 2 times x minus 2. And the bottom is x minus 2. Well, when you divide the same numbers, you don't always get 0. Excuse me, you don't always get 1. 0 over 0 is not 1. But you know what? As long as x is not near 2, x minus 2 won't be 0. Because 2 minus 2 is 0. And I'm saying x is near 2, but not 2 itself. Then x minus 2 over x minus 2 is 1. It's 1. And of course, x plus 2 times 1 is x plus 2. So you have the limit as x goes to 2 of x plus 2. Now if you directly substitute, you get 2 plus 2 or 4. Okay, sometimes when you directly substitute, you don't get an answer. You get 0 over 0. So then you should take into account, well, what happens near 2? Near when x is 2. And then you get that the function behaves just like x plus 2. If you were asked to graph that function, x squared minus 4 over x minus 2, I think it was. In fact, I'm sure it is. Well, provided x is not 2, we got x plus 2. Well, I can graph x plus 2. It's a straight line. The y-intercept is 2. The slope is 1, mx plus b. So it looks like this. That's to graph f of x equals x plus 2. To draw f of x equals x squared minus 4 over x minus 2, we have to remove 2. We have to remove the point at 2. We put an open circle to say it's not defined. And then you look. If x is a little bit less than 2, those x values correspond to numbers just below 4. And if you consider x values just above 2, well, they correspond to y values just above 4. So the limit is approaching 4. So let's look at this again with just a picture. If you were asked two questions, This is the graph f of x. And two questions. I have two questions. What is the limit as x approaches 3 of f of x? And what is f for 3 equal to? Well, to find f for 3, you go to where x is 3, you look above, you look below, and wherever you hit the graph, you find the y value. Remember, this is the graph. This here is the graph. You know what? My dashed line never hit the graph. Remember, this open circle is saying there's no point there. This graph never hit my dashed line. That is, f for 3 is undefined. F for 3 is undefined. But the limit will not be undefined. If I'm a little bit below 3, it seems like the y values are just below 2. If I'm a little bit more than 3, just numbers a little bit more than 3, I'm getting y values above 2. It's converging on 2. As x gets closer and closer to 3, f of x is 2. Now, I want to change one minor thing on the graph. I probably should just get rid of the whole graph. I'm trying my best to draw the same graph. And now, so the limit's the same. If I'm anywhere near 3, but not 3 itself, the y values are very close to 2. But what is f for 3? Well, to find f for 3, it's a very simple process. You go to x equals 3, you look below, you look above, and wherever you hit the graph, go and read the y value. Remember, everything but the x and y axis is the graph. This is the graph, this is part of the graph, and this is part of the graph. Yes, that's part of the graph. Everything but the x and y axis are part of the graph, except the circle, which means that point isn't there. Okay, well, this dashed line is clearly hitting the graph right there. It's hitting the graph right there. When I look across, I see the y value. F of 3 is 5. But let's convince ourselves the limit as x goes to 3 is 2. Because if I take values less than 3, but very close to 3, I get just below 2. If I consider values just above 3, I get y values just above 2. So that's why my answer is 2 for the limit. But f of 3 this time is defined. It's defined to be the number 5. Let us consider this graph, and we'll talk about the limit. Suppose you have a graph that goes like this. 1, 2, 1, 2, 3, 4. -1, etc. If a circle is filled in, that means you include that point. So, I have two questions. First, I'll make the statement, this graph is called g of x. So now, what is the limit as x goes to 2 of g of x? That's question 1. What is g of 2? That's question 2. And what is the limit as x goes to 3 of g of x? And what is g of 3? Well, as x goes to 2, we have a little problem. If you're a little bit below 2, then you always get -3. If you're a little bit above 2, then you're 2. If the left limit, if when x is a little bit below 2, gives a different value than when x is a little bit above 2, the limit does not exist. D and E does not exist. Okay, but what is g of 2? Well, that one's easy to figure out. To find g of any number, you go to that number. Excuse me one moment. This here is not part of the graph. To find g of any number, you go to that number, in this case 2. You look above, you look below, and you look to see where if you hit the graph. And remember, the graph is very clear. It's this point and all points to the left, and it's not this point but all points to the right. It only, this vertical line at 2, only hit the graph right here. And when I look across, I find the y value. G of 2 is -3. Notice that when x approached 2 and g of 2 were not the same answers. One did not exist, the other was -3. Okay, when x approaches 3 now, well, if you're a little bit below 3, the y values are 2. If you're a little bit more than 3, the y values are 2. This limit is 2. Now, What is g of 3? Well, let me just erase a little. And let's find out what g of 3 is. When x is 3, you look below, you look above. I hit the graph right there. Right here, I hit the graph. I look across, I find g of 3. It's 2. Here, the limit equals g of 3. That doesn't always, the limit as x goes to 3 equals g of 3. That is not always the case. G of 3 has nothing to do with the limit as x gets close to 3. Let's consider this problem. Suppose you have k of x is equal to 1 over x minus 2 plus 1. From pre-calc, you should remember that this is a 1 over x graph where I call it the new origin is at 2, 1. That is, you go to x equals 2, y equals 1, and you make believe that 2, 1 is the new origin. That is, consider this is the x-axis, consider this is the y-axis, and draw your 1 over x graph, which looks like that. Like all 1 over x graphs. Okay, now plus 1. Well, what is the limit as x approaches 2 of k of x? Well, if x is a little bit below 2, the y value is negative infinity, or very, very negatively large. If I'm a little bit more than 2, I don't get the same answer. It's going to positive infinity. What happens below 2 and what happens above 2 are different values. It even turns out that k of 2 is undefined. It doesn't exist. Because if I look above 2 or below 2, I never touch the graph. Okay, I never touch the graph. What on earth am I saying? I'm saying that the graph gets closer and closer to this line. It gets closer on the right, very high up on the line, and to the left, it gets closer and closer at negative infinity. But it never touches. It never touches. That is, the graph never crossed the line right above and below the number 2. So k of 2 is not defined. For example, k of 3 is defined. It crosses the graph right there. What does k of 3 equal? Well, whatever number is going to be right, is going to be right here. Some number more than 1. But it's defined because it crossed the graph. I looked up, I looked above 3, and it crossed the graph. So, what you need to do, usually, is to plug in the value that you're approaching. If you were asked to find the limit as x approaches negative 3 of x squared plus 5 over x minus 2, well, you plug in for x negative 3. X, this, you know how some people write x this way? Maybe you should write x that way. X squared plus 5 over x minus 2, and I'm going to plug in negative 3. and we get 9 plus 5 over negative 3 minus 2, which is 14 over negative 5. Positive over negative is negative. Positive 14 over negative 5 is a negative 14/5. And that would be the limit. Right. Now, limits are very, very friendly. Any rule that makes that one would think makes sense actually makes sense with limits. That is, if you have the limit as x goes to some number and of f of x plus g of x. Well, this happens to be the same as the limit as x goes to c of f of x plus the limit as x goes to c of g of x. That makes sense. That is, if it says plus, we should add. We shouldn't divide. We shouldn't multiply. If instead it said minus, well then we should subtract. Now, how do you read something or interpret something that has two symbols? Well, if you read the top one, if the first time you come upon two symbols, if you read the top one, then you always have to read the top one. That is, this equation says two things. The limit as x goes to c of f of x plus g of x is equal to the limit as x goes to c of f of x, read the top symbol, plus the limit as x goes to c of g of x. If you choose to read the bottom symbol, then you have to always read the bottom symbol. An example would be if f of x is x squared plus 4 and g of x is x minus 2. If you were asked to find the limit as x goes to 5 of f of x plus g of x, if you choose, you can think of this as the limit as x goes to 5 of f of x, which is x squared plus 4, plus the limit as x goes to 5 of g of x. And that's just x minus 2 is another way of writing g of x. Substitute 5 squared plus 4, 25 plus 4 is 29, plus 5 minus 2 is 3. Answer is 32. Of course, you could have added these right away, and you would get x squared plus x plus 2. Plug in 5. 5 squared is 25. Well, 25 plus 5 is 30, plus 2 is 32. The same number we got. Another rule, another two rules, is for multiplication and division. If you have the limit as x goes to c of one function times another function, well, so you have the limit of f of x times g of x. This is the same. You could alternatively take the limit. Usually you don't have to bother saying x goes to c. You take the limit of f of x, and whatever that is, you multiply it by the limit of g of x. Likewise, if it was division, well then you divide. Instead of multiplying, you divide. So let me write this a little bit smaller so I can stick in a division symbol. You have the limit of f of x times or divided by the limit as x goes to c of g of x. The only thing is, for division, the bottom limit can't be 0, because you can't divide by 0. Example, can use the same functions if I remember them. F of x is x squared plus 4, and g of x is, I think it was x minus 2. And we can find the limit as x goes to 3. It was 5, wasn't it? It doesn't matter which value I use, but I'll use 5. The limit is x goes to 5 of f of x times g of x. Now, one way of doing this is to actually multiply those two. But you don't want to do that. That's too hard. So you can take the limit as x goes to 5 of f of x, also known as x squared plus 4. Take that answer and multiply it by the limit as x goes to 5 of g of x, which is x minus 2. And like before, 5 squared, 25 plus 4 is 29. This time we multiplied, and 5 minus 2 is 3, and 29 times 3, I guess, is 87. Multiplied. If instead it had said division, then the answer would not be 87. It would be 29 divided by 3. But in any case, the bottom can't be 0. Now here's an important limit that you should know. Suppose you're asked to calculate the limit as x goes to negative 2 of 7. That is, that's the function. Now if you think about it, f of x equals 7 is a horizontal line at 7. It's this line right here. Well, as x gets closer and closer to negative 2, whether it be from below or above, the corresponding y values are always 7. The function never deviates from 7. That is, this limit is 7. In general, the limit as x goes to any number of a constant is just a constant. Because regardless of what x is, whether it's near c or not near c, but in particular near c, the y value is always k. The y value is always k. Okay. Another rule is you have the limit as x goes to c of a constant times f of x. Well, you have a product. So use the product rule. So limit as x goes to c of that constant times the limit as x goes to c of the function. But the first limit we know. We just talked about this limit. It's just a constant. And the second limit we won't know unless we know what c and f of x are. So what did we learn from here? Well, if this equals the last line, what we realize is the k, the constant, the k can come in front. The constant can come in front. And this is another rule that you should know. So if you were asked to find the limit as x approaches 10 of 4 times x squared minus x plus 1, well, what you can do is just take the limit as x goes to 10 of x squared minus x plus 1, and then whatever you get, multiply that by 4. Well, what is this limit? Plug 10 in. 10 squared is 100, minus 10 is 90, plus 1 is 91. So it's 4 times 91, which I guess is 364. Okay, the constant, as long as it's being multiplied, the constant can come in front. If it was 4 plus x squared minus x plus 1, that's a whole nother story. In fact, it would just be 4 plus that second number, but it wasn't that. Another nice rule, and it kind of makes sense because it's reasonable. Anything that's reasonable works with limits. If it says to add, it's not reasonable to multiply. If it says to subtract, it's not reasonable to divide. If you have the limit as x goes to some number of a function to a power, what you could do is find the limit as x goes to c of that function and then raise that whole answer to n. Here we're taking the limit of what's in the curly brackets, which has the power. In the second case, on the right hand side, that power comes after calculating the limit. You calculate the limit of f of x, and whatever you get, that you raise to the 7th power. Example would be the limit as x goes to 8 of x plus 2 cubed. Well, what you can do is calculate the limit as x goes to 8 of x plus 2. Plug in 8, 8 plus 2 is 10. And then whatever answer you get, like 10, cube it. And 10 cubed is 1,000. Okay, now let's look at this next and last type of problem. I'll give you the result of some limits of f and g, and then we'll have a little fun with them. If I tell you, so you can't argue this, I'm telling you the limit as x goes to c of g of x is 7, so that's given, and the limit as x goes to c of f of x, will be 2. The limit as x goes to c of f of x is equal to 2. Find the following limits. What is the limit as x goes to c of f of x cubed? Well, using the theorems I just gave you, one of the theorems, you realize you can take the limit of f of x, and whatever that is, you cube it. But we know the limit of f of x as x goes to c. It's 2. So here we get 2 cubed, or 8. If you were asked to find the limit as x goes to c of g of x minus f of x. Now you can subtract, you can compute g of x minus f of x, and then let x go to c and get your answer. But based on all we're given, we don't know what g of x is. We don't know what f of x is. We know what the limits are as x goes to c, but we don't know what f and g are. So we can't subtract it, and even if we could, we don't know what c is. Our hands are tied right now. We have to use this rule. So limit as x goes to c of g of x, whatever that is, minus the limit as x goes to c of f of x. But we know both of these limits. The first limit is 7 minus, the second limit is 2, and of course 7 minus 2 is 5. Alright, let's try 2 more. Let me erase this bottom because I want the given information to remain. Okay, if you were asked to calculate the limit as x goes to c of 8 times g of x. So, to do these problems, you have to know the rules. The 8 can come in front. This is 8 times the limit as x goes to c of g of x. Well, it's this times this. The first this is 8. The second one, this is 7. It was given. This was given to be 7. 8 times 7, 56. Now, what if you were asked to find the limit as x goes to c of 4 times f of x minus minus 2 times g of x. You're asked to find this. Now you can be slick if you're catching this. The answer is going to be 4 times 2 minus 2 times 7, 8 minus 14, negative 6. Or, if you need to do it the slow way, that's fine. As long as you're understanding what you can do and getting the right answer, this is fine. This here is a subtraction. It's this minus that. So we get the limit of this limit minus the limit of that. X goes to c of 2 times g of x. But now each of these limits we can simplify. The 4 can come in front. It's 4 times the limit as x goes to c of f of x. Minus, so it's that, minus. The 2 can come in front. 2 times the limit as x goes to c of g of x. Well, this limit is given to be 2. So we get 4 times 2 minus 2 times this limit, which was told to be 7. 8 minus 14, if I'm doing my math right, is 6. Negative 6. Okay. Like I said, it's 4 times 2 minus 2 times 7. This is exactly what I have there. It's exactly this. And I did a lot more work. But just in case your instructor wants you to show all your work, I did. But we know from, hopefully, we know from the beginning, the answer is 8 minus 14. Alright, good luck with your limits. The next video will talk about how to evaluate more complicated limits. Okay, good luck with this.